Hello students, welcome back. I hope you're enjoying the course on backtracking. Our today's topic is solving n-queen problem using backtracking. So before we see how actually we solve the problem, let us first try to understand what exactly is the n-queens problem, right? So the problem statement is, given a chessboard having n by n cells, we need to place n queens in such a way that no queen is attacked by another queen. A queen can attack horizontally, vertically, and diagonally. So I hope that every one of you might have played the game of chess in your childhood, and maybe you might be playing it now also. So in that particular chessboard, you have to place, let's say the chessboard, normally the chessboard size is 8 by 8. So you have to place the 8 queens on a chessboard in such a way that they won't attack each other. So that is just a simple problem statement. So for those who don't know what exactly a chess is and how exactly the queen moves, so you can see here, if I place a queen here, this queen can move in 8 directions: upwards, downwards, sideways, and horizontally, right? So you can see that the queen can move in the 8 directions. So for this given statement, if you see the chessboard is 8 by 8, you have to place the 8 queens in such a way that they won't attack each other. So that is our problem statement. So I hope that you have now understood what exactly is the problem statement so that we can try to solve it. So before we see that, there is few note, that is, for 1 by 1 chessboard there is no solution because you'll be placing only one queen. For 2 by 2 chessboard, if you see here, if I place a queen here, then I cannot place the second queen. Same is with the 3 by 3 chessboard, right? So if I put a 3 by 3 chessboard, so if I put any queen here, I can at most put only 2 queens. So this is one thing, that if you're planning to write a code for the n queens problems, so there are no solutions for 1 by 1, 2 by 1 and 3 by 3 chessboard. So you need to keep in mind these conditions, right? So before we see the backtracking approach for solving this problem, let us see the sample solution, right? So you can see here there are 4 queens: q1, q2, q3 and q4, right? If you take any queen here, let's say q1, it can go in this direction, downwards and horizontal this way, right? So you can see here q1 is not attacking q2, q3 and q4. You can similarly take any other queen, q2, q3 or q4, and you can observe that they are not attacking each other. So this is what is the final solution for the 4 queen problems. There could be the multiple solutions, but this is one of the solution which satisfies the given condition. So now that you have understood the problem statement and you have understood what is your end goal, let's try to see how we can solve it with the help of backtracking approach. So let's solve 4 queen problem using backtracking.
So now let's try to solve 4 by 4 queen problem using backtracking. So I've just drawn the skeleton for you so that we can reduce the time. So this is a state space tree. So basically you can either go in the column wise manner or in the row wise manner. So in this particular example, we'll go in the row wise manner, right? So the first option that we have is placing the QQ, that is the queen, in the Q1 position, right? So what we can do is, let's cross the positions where we cannot place the second queen or the further queens, right? Because q1 would be attacking those queen, right? So now you can see that in the second row I have this option, right? So let's try to place that queen in this position, right? So I'm placing this here, q1 in this place and q2 here, right? Now let's again cross the locations where I cannot place the further queens because your q1 and q2 would be attacking them. So if you see properly, I can place the third queen only at this particular location, right? So, and I cannot place the fourth queen. Hence, I basically, if I go in this particular way, I cannot find the solution. So this is the wrong path, right? So that is why I'll backtrack to this particular position, right? Because I have an option of placing q2 at this location also, right? So now let's try to place q2 in this position. So again we'll draw the cross marks where we cannot place the further queens. So right, so if you see in the third row, I only have this particular position where I can place the third queen. So let's try to place it there. So again, let's make the cross mark where we cannot place the queens because this first three queens would be attacking them. So again, if you see, now we cannot place the fourth queen because there is no place vacant where I can place the fourth queen and it won't be attacking the first three queens, right? So again, this is the incorrect solution. So again, I am backtracking now, and now I am not backtracking only to this particular position, but I am backtracking to this original phase, right? So which means that I cannot place the queen on the first position. So now let's place the queen on the second position, right? So now my q1 goes here. Again, we will draw the cross marks where I cannot place the second queen, right? So if you see now in this particular cell, I can place q2 on this particular location, right? So let's put it there. So q1 and q2. Let's now again draw the cross marks where I cannot place the third queen. Yeah. So if you see here now in the third row, I have this particular position where I can place the third queen, right? So let's place it there. So this is my q1, this is my q2, and I'm placing q3 here, right? So now let's again draw the cross marks. So only this is the position where which left, and I can place my fourth queen here, right? So now if you see this particular solution, I have placed q1, q2, q3 and q4, and all these four queens are placed in such a position that they are not attacking each other, right? So this is my final answer, that is my solution state. And here I can halt the problem, or else if you want to find the all possible solutions, you can again backtrack to the initial position and try the further combinations. So I hope now you have understood how we can use the backtracking approach to solve the 4 by 4 queens problem, and same you can apply it for the n by n queens problems.
So, I hope that now we have understood how to solve the n queens problem using backtracking. Though we have seen the example for 4 queen problem, but you can apply the same approach, that is the backtracking technique, for any n by n queen problem. So, thank you for your patience listening. Have a great day. Happy learning.